Hello, and welcome to the New Mexico Bureau of Geology's GIS Informal Lecture Series. I am your host, Phil Miller, and today's topic is going to be on georeferencing. And I realized partway through planning this and prepping this that I am probably doing this in the wrong order, but I wanted to give it a shot. So let's do a little bit of disclaimer right off of the bat. This video is being recorded and produced for a very specific use case scenario. And with that, there are some maps that are going to be challenging that are required to be georeferenced. So my thought process initially when planning this video was to be a video for the students who are going to be doing the work of georeferencing these images. So my initial thought process is give me some of the hardest images to georeference so that then I can go ahead and build a georeference plan from the most difficult use cases. The problem with that is starting with the most difficult use cases, you don't actually get the experience of what georeferencing should be like in some of the most ideal situations. So I do recognize that there is a flaw with this video right off the bat. And likely, I have a sneaking suspicion there's going to be enough problems that I'll probably end up doing a follow-up georeferencing video to this next week to try and clear up some of the issues. But we're going to run with it and see how this goes. Okay, so at the core of it, when I say georeferencing, a non-GISer, their instant reaction is, huh? And the reason why is because georeferencing doesn't say much in the grand scheme of what is happening. So you have to know what georeferencing is to know why you would do it. So georeferencing is the process of taking and I'm going to say specifically georeferencing, taking a raster and putting the raster in the correct location on the globe. Lots of people have asked, well, why would you do that? Where would that come into play? How would that become beneficial? I can give a couple of real basic examples. The most tangible example I can give to most people is if you have a field map that's printed on paper because batteries die, computer devices get hot in New Mexico sun and crash and fail. But if you've got a paper copy of your field map that you're physically drawing lines, points, and polygons on, how do you get that paper map from the physical world into the digital world? Well, you'd scan it in by a computer, or you'd scan it into a computer by using a scanner or something like that. You can do things like take photos of them even, and then load them into the computer. The problem is how do you then get them on the globe? Because by default, paper doesn't know where it's located when we're making a map. We have to tell that raster where each of the individual cells, where each of the individual pixels of the raster live. And you don't have to do it individual pixel by pixel. We can shortcut this by picking some very specific locations and matching them to the location on the globe. So as we can see in my georeferencing ArcMap project, I have the typical USGS topo base map loaded in. This is a great starting point for georeferencing. You can use any number of features to georeference to. So I just happen to have the USGS topo map up. You can use vector data. You can use satellite photos. You can use aerial photos. You can use any number of things, physical coordinates. You can use any number of things that allow you to take a unreferenced image and place it on the globe. So because we know that we have some difficult maps to georeference, I wanted to give some of the kind of context for which we are looking at for learning how to georeference, some of the normal operations and some of the things that we see come up when we decide we are going to georeference. So I have picked, I had picked for me some difficult maps to go ahead and georeference. So I'm going to go ahead and click and see we have a TIFF right here. I'm going to click and drag that into my reference to my map. And we will see a warning dialog pop up that lets us know that this map has problems. Upper right-hand corner, it says unknown coordinate system. Georeference data source is missing coordinate system information. Click here to view the details. When we do, it comes to the notification pane. When we expand the notification pane, it shows us the image that is not georeferenced. The georeference information is missing a coordinate system. So that's one clue that this image doesn't have a coordinate reference system. If we right click, go to properties, and go to source, if we click on the spatial reference dropdown, we can see that it's an unknown coordinate system, meaning it has no idea of knowing where this image is. And normally, when working in a GIS, specifically ArcPro, when you add something in, most commonly, that first thing you add in, the ArcPro environment zooms to that. We didn't get anywhere, and it's because it's missing a spatial reference. There was nothing to zoom into spatially. It's another clue that there's something going on. So if I right click on my image, my TIFF, and I click zoom to layer, it zooms to a specific image that we loaded in, and we can see that this image is clearly a scan of a paper map. And when we look at the coordinate system down here in the bottom center, we are effectively at 0, 0 for the bottom left-hand corner, for the southwest corner. Well, I know, but we can zoom into this and see that this is supposed to represent the surface geology from Ute Creek to Ponil Creek, and this is in Baldy, New Mexico. So I don't know how familiar you are with the coordinate system of coordinates of New Mexico, but we are definitely not at the equator. So, well, at this point in time anyway. So one of the things that we need to know is we need to move this to the correct location. And fundamentally, one of the things we look for and need to work out is which way is north on a scan. If you scan it in sideways, north could be one of the other directions. So we'll need to kind of pay attention to that. I'm guessing from the fact that this is upright, that north is in fact up. So it's good to have a north arrow on your paper maps. The other thing that's really helpful to know, other than which direction is north, is a coordinate reference system. What coordinate reference system was this map drawn in? That is kind of the starting point for determining how to proceed with georeferencing, because it's always best to match a coordinate reference system. This has no such information on there as to what the coordinate reference system is. I'm going to be completely honest. I have already looked at these images and poked around in a little bit. We can see that this is 9,000 south, and this says 6,000 west. That to me sounds like a UTM thing, but when I tried to play around with georeferencing this earlier, there is no way that these lines intersect at those coordinates for either NAD 83 nor NAD 27. So we have a problem. We don't know what the coordinate reference system is, and we're going to have to make some assumptions on that. And that also means that likely in the process of georeferencing, we're also projecting this image to a separate, a different coordinate reference system. All things to kind of be cognizant of and know happens. So we know that there's no way that this New Mexico map is in the Pacific Ocean at the equator. So what we need to do is get this image moved over to New Mexico. So I'm going to zoom into my image again. Zoom to layer. We know this is in Baldy, New Mexico, so we kind of need to make an idea and well get an idea of where that happens to be. So if I zoom in and I come to look at Santa Fe, if I zoom into here, Baldy is right here. So I now have an idea of where Baldy, New Mexico is. So if I zoom out a little bit, we can see where Santa Fe is in relation to this. We see that there is Eagle Nest Lake right here, and Baldy is just north of there. If we zoom in, we're going to take a look at some of the contours that make up this peak here. And full disclosure, the reason why I'm doing that is because if we zoom back to our image, we can see that there are contours on here that are in feet. And we can sure enough see that there is the double peak of Baldy and Little Baldy. So we know roughly where we are here. One of the problems with this map is the contour line thickness and the river line thickness, road line thickness. All of these lines are all exactly the same thickness, give or take. It's really hard to differentiate one from another. There are clues as to what the contours are, but they're not ubiquitous through the entire thing. So we see the contour lines have this double tick at places, but that isn't always the most useful thing to recognize, but it is something to recognize. So the symbology is different from the contours from the creeks, but that's one of the things that's a little difficult with this map in order to figure out where things are. We also have a ditch running through here. And there are some features on here that may or may not prove useful. And I can't remember exactly where they were, but there was, so Aztec Mill, there might be features that in an ortho photo, a satellite photo, an aerial photo of the ground, we may be able to distinguish and pick out some of these physical features that sit on the land surface that will help us georeference this image. So let's go ahead and start the process of getting this image in place. And I'm going to full disclosure right off the bat, there's a lot of warp that occurs in this georeferenced image. When I start georeferencing this, we have a problem. I also need to start off by saying full disclosure, I don't know the coordinate reference system of this. I make an assumption. So it's always best to set the coordinate reference of our map to match the coordinate reference that we're of the image we are georeferencing. So I made an assumption that this is NAD 27 and it did a decent job and did an okay starting point. So if I double click on my map in my table of contents, it pulls up the map properties. If I go ahead and go to my coordinate systems, we can see that we started off in WGS 84 Web Mercator. That might be okay, but again, knowing that coordinate system can't be, knowing that this map is from the early 1900s, we know that it's not likely to be in the coordinate system that was built in 1984. So we're going to go to our coordinate projected coordinate systems or geographic coordinate systems, pick UTM, and that's based off of the assumption that we saw UTM type labels down here in the edge of our map. So I assumed it's a UTM thing and went NAD 83 zone 13. I could also do the geographic coordinate system itself, just NAD 27, not projected. So that's another option we could do. Not knowing what this is, it's really hard to make some of these decisions sometimes. It's why it's really important that your coordinate reference system be on your maps if you're going to publish them or use them anywhere else. If you're the only one that's going to use them, it may not be that big of a difference because you know what coordinate system you're using. So I'm going to play around and I'm going to switch. I tried projected coordinate system when I was testing this. So since we're in a let's find out what happens kind of mentality, let's go ahead and go to geographic coordinate system, go to North America, USA, and just pick NAD 27 geographic coordinate system. Let's find out what's going on. So I'm gonna click OK. We'll see that the coordinate reference system window changes. If I zoom to this layer, we now see that the image moved where it was, and it's a byproduct of, again, where the image is in reference to other things. So we can still see that it's at 0, 0 for this bottom left-hand corner, but it did some weird things. It got much larger. So again, having looked at this map and done a little bit of previous recon, and that's the key thing when georeferencing, you kind of need to get an idea of, first of all, what and where you're georeferencing. Do you have contour lines? If all you have is contour lines, it'd probably be good to have something that has a topographic base on it. If I had an ortho photo or satellite photo or something like that, using the satellite photo to georeference contours would be a very difficult challenge because you don't have similar features to compare to. We're also going to see some unique differences between how this was mapped at the time versus how it's currently mapped. And these are the interesting nuances that we have with data over time. So that's another caveat. That is another thing that you can pay attention to. If you can find the same topographic base vintage that matches, it'll be so much easier to match the contours that built this map from the, match the contours of this map to the contours that built this map. So this is a base map of information. This has the base map information on it that then more information was mapped and placed on here. It would be best if we had an original copy of these contours to georeference to, because then literally we can pick the individual points, and we'll get into more details with that in a second. But we have now set our coordinate system to be something more probable for what we're trying to match it to. The next thing we want to do is we want to know the location that we're georeferencing. So we've already done that recon to figure out where we're at. And then what we do is we want to go to the imagery ribbon. And in the imagery ribbon, we have the georeference tool, and it's start georeferencing a selected raster layer. So notice my raster layer is selected. If I click this button, I can now start georeferencing. And as always, if I click F1, I will pull up the help files for georeferencing. I strongly recommend to supplement this interaction. There's a lot of things I'm not covering in the grand scheme of things. I do recommend you go and read the help file about georeferencing to figure out a little bit more of the core mechanics of what we're doing. I'm going to do the overview of what it takes to georeference. Okay, so I'm going to click Start Georeferencing. And we notice that when I clicked that, we switched to a different ribbon. And I want you to notice that in the we were in the imagery ribbon. I click Start Georeferencing. We got a new georeference tab at the top. This is important later on as you're bouncing around doing different things. We'll talk about this in a little bit, and this is what I'm going to. When I bounce around, I can't click georeference. There's a clue right above the button to help you figure this out. But I understand that many people will be like, well, wait, how come I can't get back to georeferencing? It's because it opened a new tab for us that allows us to do that. So we'll go through some of these buttons here as we go through the process of georeferencing. But at the core of it, what we're doing is we're trying to get a location on this paper map to its actual location on the globe. So because I've done a little recon, I know where I'm going with this. And don't forget, there's also the locate button that can be helpful to find locations by typing in an address, place name, or coordinate values. So let's demonstrate that really quick. If I click locate and I type in Baldy, New Mexico, how many Baldy Mountains are there in New Mexico? Luckily, it went right to the one in question. But if we're talking about looking out the window to the west, we've also got Baldy Peak just to the west of us here. So this is one of the things that's a little tricky. We need to be careful about and pay attention to. You noticed it pulled up a list of a couple different ones, but very quickly it navigated me to where I wanted to go, placed an A referencing the one I'm looking at. If that wasn't the one I wanted, I could go ahead and click on another one. It bounced to another one. I click on another one. It bounces to another one. I click on another one. It bounces to another one. I click on another one. It bounces to another one. So this is a quick way of getting locations, getting two locations while you're georeferencing. So we know we want this one is A, but let's go ahead and go back to my image now. Zoom to layer. And I keep saying that because that is a very helpful function. if you've got a feature that you can zoom to, it's another way to supplement having these type of ways to navigate. You don't always have to have a physical location. You could have a polygon that you zoom to. You can have tick points that you zoom to. You can have any number of features that are located in this area already that allow you to get there faster. So the next button I want to talk about here is the add control points. What we want to do is add control points. These are tied locations. And what we're going to do is try and tie these two locations together. The location of a pixel in this layer to a pixel feature any number of different parameters in this US topo layer. That's how we're pinning this raster to a known location. And you'll see that this kind of gets into a rubber sheet thing, and it's often georeferencing is also commonly referred to as rubber sheeting a map to a location. So what we want to do is add control points to put those tie locations together. So I click the add control points, and we see if we hover over the image, it says from point source. What do we want to georeference from where, and what do we want to georeference to another location? So currently I'm on from. Where do we want to go from? I want to go from, I'm going to pick the northernmost point of this 12,440 foot contour interval. So you can zoom in literally and pick a pixel if you wanted to. Because I'm just trying to get a general gross georeference, I'm going to pick somewhere in the middle, preferably what I would consider the most northerly pointed orientation of this. You can also pay attention to specific curvatures or nuance, peak angles, sharp curves, specific patterns of line undulation. There's things you can use to your advantage. So currently I'm just going to go ahead and pick the most northerly thing. Click where the from point of what I want to georeference. I click, I now have my tie line that it's trying to ask, where to do I want this point to go to? Where do I want this point to go to? So I'm going to go ahead and double click on Baldy again. Zoom in. We can see now that I've got a single line where in my raster I had a double line. That's where the vintage of these topo bases could be helpful. If I could get that same vintage topo base, I'd have the two rings of 12,440 feet. Oh, 12,440 feet. Uh-oh. If I zoom in, we can see that we don't get any more resolution. So that means that likely I'm trying to georeference to something right here. Oh, shoot. So I really need the 12,400 tie line. Oh, shoot. I don't like what I've started with. How can I cancel that tie line now that I've looked at this in more detail and know what I need to do? If I click off of the tool, so I clicked move, clicked add control points, I am now back to from. When you have control points already selected, you can switch to the select tool or any number of tools to deselect, to deactivate the georeference add control points tool. The reason why I'm going into this is for many of you, you are familiar with georeferencing in ARC. For many of you, you may be familiar with georeferencing in ArcMap. You used to be able to right click and say cancel control point, and that would stop that control point from being active. So that's something to pay attention to. You got to get off of this add control points tool to stop that point from trying to be active. So I'm going to zoom back to my image. I'm going to zoom back to my raster. I'm going to look for that 4,000 or 12,400. Notice that this does not look like that same oblong. This is more bulbous down here in the southeastern part than it looked on that other topo map. Well, shoot. This is again that vintage issue. Having contours that match identical is your best bet when you're using contours. We know that this has still got to be somewhat accurate, and we're just trying to get a gross georeference, at least to start. We've got to get it moved to New Mexico. So I'm just going to go ahead and pick that 12,400 tick again, come back over to my location, double click on Baldy, zoom in, and now I can see I'm somewhere in here. But notice the difference of that bulbous lobe on the image that we have that we don't have. This is much more narrow. That is another thing that's making me wonder about coordinate reference system. Could that be a coordinate reference system issue? So I'm just going to do the best I can. I'm going to go ahead now and click my 2 point from to, and we'll see that that image now jumps over to my target location. And we can see that it's absolutely enormous by way of comparison. So we need some other feature to help shrink this down, or a lot of the times enlarge this raster to rubber sheet it to the locations that we're trying to georeference. So I'm going to go ahead then and go down to Little Baldy Mountain. And again, looking at this, this is a very distinct curve right here. I wonder if we could see that curve on Little Baldy Mountain. So I'm going to go ahead and click on Baldy Mountain, and I'm going to go ahead and I know my Little Baldy is right here. Uh-oh. Uh-oh. We can't see through our image. So this is a very common occurrence. We need to adjust the transparency or adjust the methodologies which we're looking through this image to our topo base. So with our raster layer selected, we can come to raster layer, and I can say make this 50% transparent. I type in 50, I hit enter. Now I can kind of see through that image. This will actually help us a lot later on as we're doing more georeferencing. It becomes a very convenient function. You can also use blending modes now and multiply it. So there's all sorts of different ways you can do things to help you see through an image. This is kind of a rough raster in that there isn't a clear white background and a clear dark line of the ink, because that's another thing that we could do is we could make all of the white transparent. We don't have white. We got lots of gradients of gray in there. So let's go ahead now and go out, zoom out to our little Baldy Mount. And I'm going to pick again, kind of that northernmost, but we're looking at sharp curvature here. I'm going to go ahead and click near that point location from, go back to my Baldy Mount, zoom in, and I want to pick that sharp curve. Ooh, what was the contour elevation of that? Well, let's go out, zoom back in. So see how I can move around while I'm georeferencing to get some information. So we are at 11,900. Again, click back on Mount Baldy, zoom in. We are looking for the 11,900 foot contour interval. Okay, so we got 20, 60, that would be 40, 60 to 800 is 40. So if this is 11,880 and we add 40 to it, the next contour, shoot. So it's somewhere in between here, isn't it? Uh-oh. So these are the things that, again, matching the contour base that you have on your map to the base that you're georeferencing to would make this easier. So now let's go through this again. Remember, I clicked raster layer and I turned it to 50% transparent. I can't cancel this control point now. Shoot. So I need to go to my georeference tab so that I can select on a different tool to deactivate my add control points so that I can go back to my image and restart that georeferencing point. And I know this is a lot of information and seems kind of basic, but these are the things that will help you be productive when you are actually georeferencing. So Let's go ahead and look in and see. Here's 11,800. Is there anything in here that I can use that's a distinct enough feature that I could probably find on my topo base? Oh man, there is not much, is there? We can see that at the 11,800, there's a creek that's coming up, and this sharp point is the location of that creek intersecting our topography. So we could use something like that. That might be something to look for. So I'm going to turn my contours back on, zoom back in, come into here, and sure enough, I can see where this creek does. Here's my saddle. I need my 11,800 foot contour, and I don't see that sharp recess like we saw in the raster. We can see a more sharp recess here. It's probably somewhere in here. And again, we're just trying to get close right now. So I'm going to use this as my reference. So notice I'm not using a physical feature. I'm using a curvature, a sharpened curvature to find that location. So again, zoom to my layer, find my peak that I want to georeference and that curvature there. I'm going to switch back to my add control points. I'm going to pick that curvature. I'm going to go back to Baldy. And when I click this reference point at this intersection, we're going to see this image shrink. So now I've got two control points in, and now we're starting to see that map pattern repeat. It's a little hard to see from and I'm going to call it a dirty scan. Again, this is a very dirty scan. So we're having a hard time seeing through that dirty scan. So this is where, again, coming to raster layer and applying blending modes might help us see through it a little bit better, maybe making this a little bit darker so we can see through it. Oops, I went the wrong way. A little darker so we can see through it. There's some tricks that we're going to have to play with in order to be able to see both of these kind of simultaneously, as well as we can also turn layers on and off independent of each other while working on a georeference. So if this is that creek and we turn off that image, we can see that that's the creek right there. So we can start to use physical features on the map to help identify things. We've also got this clear road that's zigzagging through here. And with two control points in place, we're at the point that things will start to kind of line up that we might be able to use. Uh-oh, unfortunately, that nice curvy road that has a very sharp point in it that could have been used to help us georeference is not there and doesn't exist on this. And we can start to see some weird divergence with our contours as well. At the bare minimum, we need 3 control points to get a georeference really kind of locked in. And currently, the more our control points are spread apart, the better our georeference. And currently, we've got 2 points that are tight together. So we kind of need to get something further away from these points. So I'm going to come out over here. And I'm going to try to find some feature that would help me georeference this raster to our location. Okay, so looking at this, do we see any place where this has that double dot line to it? So no, this must be a creek. So it's probably this creek. The question is what is this creek doing by way of comparison to what this creek is actually doing? So if we look in here, we can see that this comes this way. Clearly, there's a junction that joins here that's on the US topo map, and this line would follow this line. Okay, so we've got an idea of this curves up and then comes down to the south and then starts curving back up. And we can see that it curves up, starts curving down, and then comes back up right here. So we start to see that pattern repeat. That is one of the patterns that we can use to help us get a georeference. The other thing that is beneficial to use is the intersection of the creek and the intersection of a contour line could be really helpful as well. So if I'm looking at this, let's do the creek first. There's my creek. Here's my contour. Do I see a creek and a contour line that matches? Well, we should go take a look at what the elevation value is for this contour. So 9,900 is this contour right here. Does that match? Oops, wrong one. This contour anyway. So if we zoom out and we get to the point that we get a label on there. I picked a bad location. Nope, that would be 10,012. So we need, what was it, 9,900? 9,000. 9,900. So we don't have a matching one there. So what about our 10,000? So if we come up and start looking, that should be the 10,000. That's 10,4, 10,2, 10,000. So I'm going to follow this around. There's that. And there is that bend. So now I'm in the right area for this one. So now I found this location. Matches this location. Sorry, I want to prove that. Yep, 10,000 is this contour, which matches this contour here. So we're going to go from here to this location. So I'm going to zoom in. I'm not going to pick a pixel, but I'm going to try and find the best location for these two. I'm going to click my from, zoom out, and then georeference to my target. So now I've added 3 control points. Let's go ahead and click that on. And now we start to see that relationship show up between our topo base and our image that we're georeferencing. We can also see some distinct discrepancies, can't we? So this creek is this creek. And there are some severe discrepancies between these. This is the problem with some of these old, and I'm going to call it a hand-drawn map, but it was a, I'm not going to say hand-drawn, but it was drafted in a very manual manner. And that's some of the nuance that we see and some of the problems that we see. One of the other things that I tend to use is look at this curve right here of this creek. Man, if that was actually on this creek right here, that would be such an easy feature to use to georeference to. So we've got to find something else. And again, we want to get away from our points. And notice how we've started to turn this square image now into a trapezoid. So we need to find some other feature that we can use to georeference away from those other 3 points. So I'm looking at 11,200. I'm looking at 11,200. This is this point. Man, these are like the opposite shape of each other, aren't they? But likely this lowest part corresponds with this lowest part. So again, I'm going to go from here and I'm going to try and do the best I can to put it here. So click my from, and then click my target of where I want my from pixel to go to. And sure enough, we start to get a little bit better of a georeference. We start to see things show up that agree. And we're not too bad, but we're not great if these 2 creeks are supposed to be the same. So the problem with this is I believe this TIFF is more hand drafted not surveyed, not from known coordinates. There's a whole bunch of different methodologies that are date back to when this map was made in 1916. Uh, some information was put on here in September of 1956. So these aren't the most technically sound topographic maps. By way of comparison, but we do know it was surveyed, so they used some bit of information to get this located. But at the core of it, this is the reason why I wanted to demonstrate some of the more difficult georeferencing tactics. And we saw that that was pretty convoluted to find those locations, right? There is no mistaking that that was me showing my level of expertise with finding things. But with this project, these are the most difficult maps. These are the scenarios that we need to pay attention to. These are the things that we need to be mindful of when trying to georeference these. And there's a point where as you keep adding control points, you will start to get the image to work its way into the right location. And then there's a diminishing return that occurs as you start adding more control points. More control points doesn't always mean a better georeference, which then gets us to the next discussion topic when georeferencing, and that's transformations. So I'm going to go back to my georeference tab, and we have a transformation drop-down tab. In order to do a first order polynomial, we need at least 3 points to start the process of getting an image georeferenced. So I have now 4 points. I can do first order. Again, requires at least 3 control points. As we go to second order, third order, we start to see the more rubber sheet come into play. And again, requires at least 6 points, requires at least 10 points. We can try the different transformations. What the different transformations are different methods of getting these points located to their location using different maths to tension the features together. So I currently have, and I did 4 points that I could do a couple different transformations. So if I do similarity polynomial, you can see that my from and my to now have this tie line connecting from and to. I'm going to go ahead and switch back to first order polynomial. You see these points move. That is the math that's tying those together, and these got a little bit shorter. Let's go ahead now and go to adjust. So I click on adjust, not much of a change between those three. And let's go projective. So projective really got those points pinned down, but we also know that these points, specifically the first two we started with, aren't the greatest, are they? They were kind of arbitrary. We had to pick a gross feature to start from to get it at least in the place where we could start looking at these two images together. So we know those aren't the best points, but we do know that they are in there somewhere, right? This is where now at this point we can start looking at the control point table. So I'm going to go ahead and click on the control point table. I'm going to drag that into my window of view. I have made 4 control points. These are my 4 control points. I tend to have this open when I'm georeferencing for the purpose of being able to very quickly turn off and no longer use some of the control points. See? So we can see the effects of one control point over another and how they affect one another. So I'm going to go back to my first order polynomial. And if I didn't like my control point 1, I can turn it off, turn it back on, turn it off. And we can see the effects of that live. That's the part that's really nice about it. So we can see how this isn't even remotely tied to where it should be. I turn that back on and it gets a little bit closer to where it should have been. So this is what we're doing when we're dealing with transformations is we're taking these control points, tying them to the feature that we're trying to do, and then adjusting the mathematical model that allows those points to coexist and try to pull them to their correct locations. Again, the more control points you add, the better your georeference, but there is a point of diminishing returns where adding more control points doesn't provide much more benefit. You have to take the time to look at your control points and analyze what's happening in your georeference when you're georeferencing difficult maps. You spend a lot of time playing with the transformations and turning control points off. To know which control points to turn off, we got our residuals and our root mean square. That's interesting. It doesn't show. I am used to the arc map where it shows, well, I guess it is my residual. Never mind. There's my, this is my residual error. I'm also accustomed to ArcMap where it shows me my root mean square error, usually at the top, that gives you an overall assessment of all of the points together. There is ways to get there. I don't want to get into it with that, but what we're going to look at is with regard to these residuals. How close are these numbers to where they are in relation to the X and Y of our source to the X and Y of our target? Those are the key things that we're looking at, our source to our target. The residual in the X direction for each of these points, the residual in the Y of each of these points, and the aggregate residual of our X and Y. So for the time being, I'm going to go ahead and dock that so that we can keep using that. Okay, so one of the other things that we can do is we've got this nice ridge line here, and we can use the ridge line of our topo and the ridge line of our base map to help us pin that down. So we can see that I've got 9600 right here, and our 9600 contour. I could have picked a better map. I should have, but I didn't. So there's 9600. 9600 intersects Ute Creek, which is called Black Horse Creek on the map that we're georeferencing. So this point intersects the creek right here. So we could use that. We could also use this curvature of the ridge with this curvature of my 9600 contour interval. And those are pretty close. The problem is they don't look enough alike to be able to do that. And this creek, this is difficult georeferencing. And that's the reason why I wanted to start with these, was to show the problems. An easy georeference map is so easy to georeference. But because we knew we had a couple of these, this is why we're going into these problems. So again, I'm going to add a control point. I'm going to add the intersection of my from source and tie it to the to source of the contour and the intersection of that creek. And we can see we pulled things down just a little bit. Our ridgeline is a little closer following our ridgeline from our USGS topo base. So we got it a little bit better. We can also see there's some weird discrepancy of our contours in here. Not everything is perfect. These two images do not match, but we're doing the best we can. And there's a certain point to where you're just going to have to call it good enough for what you're trying to do. In the interest of time, I would go through and probably add at least a dozen more control points, and I'd probably go through the process of playing with the different transformations. But at the core of it, georeferencing is selecting a specific pixel on a map to then tie to a physical location on the ground, our source to our target. That is ultimately what we're doing. So if I was happy with this georeference, no, I am not happy with this georeference. Again, you would need to spend more time adding control points. But if I was happy with this, now would be the time to go ahead and save this. If I was happy with it, to save this raster. I don't do save. I do save as new. And the reason why I do save as new is an old sticking point in ArcMap. I want this map to be usable by anyone who uses it after me. In ArcMap, when you clicked update georeferencing, it didn't write a new file and it didn't assign the coordinate system to the file. So that if someone wanted to use your raster, they drag it and drop it in, they would get that same notification warning that says unknown coordinate system, but it would look like it's georeferenced. But which coordinate system is it in? There's no way of knowing. And if you were to add that image in without a coordinate reference system, because ARC assigns the coordinate system to the first data set you load in, you would add that raster in without a coordinate system reference. Your map wouldn't have a coordinate reference system. That's a problem. And it trips a lot of people up and gets a lot of people into trouble. So I'm going to do this for the best practices method that I think translates to the most amount of users and saves the most basic users from some simple frustrations. And that is to save as a new raster. That writes a whole new raster, a new copy of the raster with the georeferencing information inherent in the image, and it writes a coordinate system so that you don't get this unknown coordinate system error. So I'm going to click Save as New Raster. I am going to save this. Oops. Oops. It's doing things. Here. This is my original. For any image that we georeference in the Bureau of Geology, the GIS Services Program has a very specific protocol on this. The original image stays the name of the original image. The georeference TIFF is called the name of the file _ RECT. And what that stands for, it has been georectified. It now has a location on the Earth. That is the distinction between the non-georeferenced one and the georeferenced one, allowing us to get back to that original if we don't like this georeference. Allowing us to get back to this original to clean it up to make it easier to read so it's not so dirty and then do a georeference. I prefer a non-destructive method of working with data. This is that. So effectively, we're making a copy of it now, but with the georeference information. I type in .tiff. I click Save. Now I can come over here and specify whether I want it as a TIFF, whether I want it as a BMP or a GIF or a JPEG or a PNG or whatever format I want. I tend to leave things as TIFF. Yes, they're large, but they retain resolution. It also is saying, hey, we're going to assign the geographic coordinate system North America NAD 27 to it. Do you want to do this? Yes, this is why we're doing this process. So not only do I save it to a location, give it a specific name, specify the output format. We can now select the compression type. Again, this is a personal protocol that we run in the GIS services program. And it is, we assign a compression type of LZW. That does allow compression of the image to occur, but it's a lossless compression format, which means it doesn't overwrite any of the pixels. It doesn't blend any of the pixels. It doesn't give you JPEG artifact. It keeps the original cell values, but makes the file size just a little bit smaller. You can also do none. If you know better, do better. But if you're just going off of my recommendations, I would save it as a TIFF. I would save it with a LZW compression. And then we can go ahead and click export. It will now write that new file with a coordinate reference system and our georeference information tied directly into that image. Now, I would like everyone to pay attention. Different from ARC map, it added the image in. Used to be when you would save a new file, when you would rectify, when you would use the rectify option in ArcMap, it would just save the file off to your save folder, but it wouldn't add it in. Everyone would then assume that this image, the original image, was their georeferenced image, and it wasn't. Arc Pro now adds in that rectified image for us. We would now want to remove our original file so that we don't have it in our data frame anymore. And then we have our georeferenced image with its warp and skew and all of those things located. If we come to the notifications and we clear this one, we don't see a notification for our RECT image. If I double click on it, like we did previously, go to source, go to spatial reference, we now see that that image has a spatial reference. If I add it to a blank map, I can demonstrate how an image would come in if it had a spatial reference without any warnings. So that's what we're doing. We're getting this map georeferenced. And I fully think that next week I will go and grab a simpler image and go into all the nuance of details of how to georeference in more specifics. But I thought the difficult problem one would be a good video to watch as well, because this is going to be a challenging map. It would be easy if these coordinates were actual good coordinates. It would be so much easier to click the intersection of these two coordinates, right click, you can then specify its coordinate system, pin it to that physical location, and then move on to your next coordinate system. Come to the opposite side of the map. Click this intersection of these two coordinate systems, right click, type in the physical value. That would be so much easier. When I looked at this image originally, I was like, oh, this is a bad one. This one's going to be super easy. When I started playing around with these coordinates, I found out that that wasn't true. This is going to be a difficult one to georeference. So I do think next week we'll go into an easy georeference. I'll probably pick a good one. And then we'll go into some of the more nuance with regard to not just using one specific base map, but many different base maps or different data sets that help us do our georeference. So I'm sorry that took so long. I was worried that this would be kind of a convoluted one and kind of a complex one, especially when I started the practice of this video. I was like, shoot, this is going to be too much for one video. And sure enough, we are now over time. So I want to thank everyone for joining us and participating in today's informal lecture series. It has been wonderful working with you on the georeferencing topic. We will continue this topic in the next session, and I want to give a special thanks to the GIS Services Program. A special thank you to Amy Trivett for bringing this project to our attention and allowing us to interact on this. And I would like to thank Mike Timmons for allowing me to continue doing this informal lecture series. So thank you very much, and we'll see you in the next session.